Howdy, 8th grade. Today we're going to be looking at, hopefully, systems of equations with elimination. I'll make sure to check this time if there's sound coming through. Test 1, 2, 3. Hopefully it's working. If not, we'll do it in class again. That'll be fun. But for now, we're going to try to do systems of equations with elimination. So with elimination, how that works is it's a way to solve a system of equations. So when we say systems of equations, that means we have multiple equations at once. So we've done this a little bit before with substitution, where we have like y equals 2x plus 3 and y equals 3x minus 2. If we solve this through, we'll end up finding what x and y are, and we'll be good to go, which is really nice. But what I want to do today is, instead of doing it with substitution the way we used to do it, we're going to have a new method that is called elimination. So elimination is when we're going to add two equations together to get rid of a variable. Is adding two equations to kill a variable. And I'll show you guys an example of that real quick. So if I have my two equations as 5x plus 2y equals 9 and negative 5x plus 6y equals 7, what we're going to do here is we're going to add these equations together. So we know that what's on the left side of the equation right here is the same as what's on the right there. So we can add that to both sides of a different equation and it'll stay the same. So I'm going to add this to this on the left side. I'm going to add the right side to the right side. And that should be able to work out. So let's see what happens when I do this. 5x plus negative 5x can be 0. 2y plus 6y is going to be 8y. And 9 plus 7 is going to be 16. 8y is 16. Y is 2. To get x, I'll go back up top. I have 5x plus 2y is 9. So 5x plus 2 times 2 is 9. Give me that 5x plus 4 is 9. 5x is 5. And finally, that x is 1. So all I did here was I added these two equations together. Gave me this equation right here, which is easy to solve. And then I plugged in my final answer here to get my final answer for x as well. Now that that's all taken care of, if you'll notice, we got really lucky on this set of equations. And the reason that we could add them together and it worked out is we had a positive 5 here and a negative 5 there, and those canceled. And most of the time we do this, it's not going to happen. So to show you guys something, an example of a different time when we might want to use elimination would be if I have 7x plus 3y equals negative 5 and 2x plus 3y equals positive 5. What I'm going to want to do here is to make one of these equations negative. So I can see that I have a 3y here and a 3y here, but if I add those, I'll get 6y, and that won't be helpful to anyone. So if I multiply one equation by negative 1, let's do this bottom one here, I would end up with negative 2x plus negative 3y equals negative 5. So I don't need to look at this equation anymore because I changed it. And now I have this equation here and that equation there. So my 7x plus 3y equals negative 5. My negative 2x plus negative 3y equals negative 5. And I can add these up. So negative 2 plus 7 is going to be 5x. Negative 3y plus 3y is going to be 0. Plus 0 equals negative 5 minus 5, negative 10. So if 5x equals negative 10, I know that x equals negative 2. I can plug that back in up top. Negative 2x plus negative 3y has to equal negative 5. If x is negative 2, that tells me that 4 plus negative 3y equals negative 5. I can subtract 4 from both sides, and I get negative 3y equals negative 9, or y equals 3. So x is negative 2, y is 3, and I'm done. And for this one, we did have to modify one of our equations. So we started with this right here, and we modified it So we made it all negative, so it became this equation right here, and that's one that we could actually use. But that was pretty easy. We just made one negative, and we happened to have this 3 here, and this 3 here we could use, so our lives were made a little bit easy by the problem. I'm going to show you guys one where it won't necessarily be made quite so easy. So to do this, we're going to do our third example, which is going to be when we have 5y equals 8x minus 2, and 4x minus 3y equals negative 2. So what I'm going to do is I want to make sure that I have the same variables on the same side of the equation. It's just going to make my life easier when I'm adding. And the way I'm going to do that is I'm going to take this 8x and move it over here by subtracting 8x from both sides. So if I have 5y equals 8x minus 2, subtract 8x from both sides, and now I have 5y minus 8x equals negative 2. I also still have my 4x minus 3y equals negative 2. My x and my y aren't quite lined up, so I'm just going to change this to say negative 3y. It's minus, so it's going to be negative. Minus up here means negative 3y plus 4x is going to equal negative 2. But these numbers aren't lining up. If I add this, it won't do anything for me. So I'm going to have to change it a little bit more with these two equations. That's where I am right now. And the way I'm going to change this is I see an 8 here and a 4 here. And I know that I can make this 4 and 8 pretty easily by multiplying both sides of this equation by 2. So that's what I'm going to do. I'm going to multiply this by 2 and multiply that by 2. And I end up with, now I have negative 6y plus 8x equals negative 4. And my top equation is still 5y minus 8x equals negative 2. So now that I have these, I have my positive 8 and my negative 8, which means if I add them together, I will eliminate the x. So negative 6y plus 5y is going to give me negative y, plus 0 equals negative 6. And if negative y is negative 6, then y has to equal 6. I can go back and plug this into an earlier equation. I like to go back all the way to the beginning when I plug these things in. So let's use this one right here. 5y equals 8x minus 2. So 5 times 6 equals 8x minus 2. 5 times 6 is going to be 30, equals 8x minus 2. If I add 2 to both sides, 32 equals 8x, and dividing by 8, I get that x is equal to 4, which is awesome. And I know that y is 6, x is 4. I am done with the problem. So this is a bit of a tricky way to solve equations, but if you do it, you can do it faster than you can do substitution. So if you find something where this will be useful, you can do this faster than substitution, and a lot of times substitution gives you really annoying fractions. This doesn't do it quite so much. So if you come to a equation and you can use this, it'll be a lot nicer. But if you want to stick to the substitution, that's okay too. So it's entirely up to y'all. And please do the lesson practice. It's on page 415, if that helps you get there. And there's just 5 problems, so it shouldn't be all too bad. Those 5 problems, put it on the end of your notes. I'll be looking for them, and I'll see y'all in class tomorrow.